Since the dawn of mankind, the cosmos has never ceased to amaze anyone who looks up to the sky. The starry nights move, subjugate, transport, and fascinate the lovers of the stars. The discoveries follow one after the other, some confirming old hypotheses, others breaking assumptions, exposing us to more and more unsolved mysteries. If we have begun to understand the functioning of our galaxy, the Milky Way, we also know that it occupies only an insignificant part of the space that surrounds us. The universe is so vast that the observation of its horizon is still inaccessible to our most sophisticated instruments. Nevertheless, we offer you the possibility to discover, beyond our solar system, a neighboring galaxy, just as marvelous and spectacular. Dear traveler, good morning. Today, we're going to explore one of the most beautiful spiral galaxies known to date, the Andromeda Galaxy. But before leaving for a new adventure, think about liking the video and subscribing to the channel to not miss anything. Thank you all, and have a good trip. We invite you to take a seat in our spaceship. Make yourself comfortable and fasten your seatbelt. Today, we will travel at the speed of light. The smooth takeoff propels you beyond our atmosphere in no time. The glittering darkness of space opens up to you. Here you are in complete immersion in this cosmic universe with its calm and silent appearances. Let's take the direction of the Andromeda Galaxy, about 2.55 million light years away from our Sun. A good 30 minutes, and we are approaching Jupiter, after having traveled 628 million kilometers, or 390 million miles. You could finally contemplate more closely this planet, which is the fourth brightest object in our celestial vault, after the Sun, the Moon, and Venus. Admire the rings that adorn Jupiter. Enjoy the ochre colors of this planet, whose size is approximately 11 times that of the Earth. Maybe you'll be lucky enough to see one of its splendid aurora borealis, or to be surprised by a gigantic lightning bolt due to a storm like it always has. Near Jupiter, you may also come across some of the satellites that revolve around it. Among its 79 moons, Io is the closest and the largest. You can see the strong volcanic activity on its surface. Your journey also takes you to Europa, another of the 4 Galilean satellites. Europa is the smallest of the 4, slightly smaller than our moon. Unlike Io, its surface is smooth. Europa is actually the object with the smoothest surface of all known celestial objects in the solar system. This is due to its young age and to the composition of its surface, which is a thick layer of ice resting on an ocean of water. But let's leave the Jovian system and resume our route. This one brings you close to the second giant gas planet of our solar system, Saturn. It is not necessary to specify it to you. You recognize it thanks to its famous luminous rings, which give it the nickname of Jewel of the Solar System. Moreover, these are more numerous than we thought. While thought there were 7 main rings of sandy tan color, the latest observations of the probes Voyager 1 and Voyager 2 have shown that it actually has several thousand. The rings A and B, which were discovered first, are the densest of all. However, despite a large amount of icy water particles, rock, and dust, They are respectively no more than 300 meters to 1,000 feet thick. In spite of their gigantic extent, which goes beyond 282,000 kilometers or 175,000 miles of the planet, some of them can thus become almost invisible if we observe them from their edge. Moreover, the closer we get to Saturn, the more we realize the complexity of its rings, separated from each other by relatively large divisions, or even divided into a myriad of rings by gaps more or less significant. These rings do not cease to radiate within our prodigious Milky Way. But let's leave behind this splendor of our galaxy. Our journey has only begun. Another giant planet is waiting to reveal its secrets. Let's travel 1,442 million kilometers, or 900 million miles beyond Saturn, and reach the mysterious planet Uranus. You have 80 minutes of travel at the speed of light, during which we invite you to observe the limitless immensity that opens up to you. Observe, in this obscure environment, a planetary shape taking shape on the horizon. Uranus, with its soft and uniform bluish color, welcomes you with grace. Here, at the edge of the solar system, is the first ice giant. 15 moons are in its orbit, but the largest one measures only 150 kilometers, or 90 miles in diameter. Uranus, on the other hand, is 50,000 kilometers in diameter, or almost 31,000 miles. It has 9 rings, which, unlike Saturn's, are more recent than the planet that holds them. Let's continue our journey towards Neptune, another gas giant planet, whose azure blue color cannot leave you indifferent, reminding you in this mostly dark universe of our beautiful planet Earth. Neptune, named after the Roman god of the ocean, is 1,628 million kilometers, or 1 billion miles away from its twin. Its diameter is about 50,000 kilometers, or 31,000 miles. This ice giant, although it has slightly higher temperatures than its neighbor, is one of the coldest planets in the solar system. A large dark spot in its atmosphere is evidence of environmental dynamics. Numerous clouds appear battered by winds, blowing at 2,000 kilometers an hour, or more than 1,240 miles per hour. Although these two ice giants are known for their unattractive temperatures, they do not take first place. Neptune's largest moon, Triton, does. This celestial object is the coldest ever detected in the solar system. Its rough and icy landscape, as well as its imposing core, are troubling researchers, especially since some activity is visible on its surface. What if under this icy mantle, constantly perforated by fumaroles, there was a large body of liquid water? Here's another mystery to be solved, which could help scientists in their understanding of the presence of water in the solar system in a more general way. After exploring our solar system, we have found that no other planet than Earth is likely to support life as we know it. However, the universe is so vast and the galaxies so numerous that we can still allow ourselves to imagine possible life well beyond our Milky Way. Are you ready to leave our solar system? We will now leave the Sun's heliosphere by crossing its limit, the heliopause. The solar winds will no longer have any impact on your journey. You will now travel in the interstellar medium. But first, fasten your seatbelt. We must cross the boundary between the solar system and the interstellar medium. The particles of the solar wind, which move at a supersonic speed, will suffer a violent slowdown as soon as they will be in contact with the particles of the interstellar medium. The speed of the particles emitted by the sun will thus pass from 400 kilometers per second, or 250 miles per second, to approximately 100 kilometers per second, or 60 miles per second. All these particles accumulated around the heliopause emit a strong energy. these particles heat up, causing a shock wave, or even several. Our vessel will thus cross this turbulent zone, always at the speed of light. Finally, after some shocks without gravity, the vessel arrives for the first time in the interstellar medium. But what about the neighboring solar systems? Another planetary system at a distance of 4.244 light-years from our Sun and located in the constellation of the Centaur arouses our curiosity in the Milky Way. Its central star, named Proxima Centauri, or the Centauri star, is the closest to our Earth after the Sun. This red dwarf, although not very massive, with a size 7 times smaller than our Sun and weakly luminous, is nevertheless the main star of a triple system. Indeed, Proxima is accompanied by a couple of stars, named the double star Alpha Centauri. These two other red dwarfs, Alpha Centauri A and Alpha Centauri B, larger than Proxima, are, unlike Proxima, well visible in our southern sky. Moreover, the double star Alpha Centauri is the fourth brightest star in our sky. As we approach Proxima, we can see large flashes of starlight. Its brightness increases periodically. Proxima is a flamboyant star. Because of the convection processes that are visible, it is therefore destined to keep its average age, according to scientists, for another 300 times the age of the present universe. But what makes this triple system fascinating is, above all, the recent discovery of a super Earth-like exoplanet orbiting Proxima. This planet, named Proxima b, is causing quite a stir in the scientific community. Indeed, its orbit, located in the so-called habitable zone of Proxima, offers it the status of a candidate to hope to find, potentially, extraterrestrial life. But water must be present on the planet and must accumulate on its surface. Moreover, its atmosphere, essential for any life, must resist its orbit. Proxima b, whose size is estimated at 1.08 times that of the Earth, completes its orbital path in only 11.2 days. It is, therefore, experiencing a significant atmospheric escape. However, why not imagine that this process is counterbalanced, for example, by sufficient volcanic activity? Let's now leave this star system. I propose to you we travel more than 4 additional light years. You have all the time to enjoy the interstellar spectacle. The constellations follow one after the other, sometimes intermingling. Some, more sparkling than others, catch your eye. Others merge into imposing nebulae, offering you a magnificent spectacle. In the distance, you can see a star that you know well. Despite a distance of 8.6 light-years from our Earth, it remains the brightest star in our sky. Let's join the constellation of the Great Dog and discover Sirius, the brightest white star after our Sun. It is the 5th closest star system to the Sun. This bright dwarf is 20 times brighter than our Sun. But Sirius is not alone. It's in company of Sirius B, a white dwarf whose size is close to that of the Earth. Its luminosity being 10,000 times weaker than that of the primary star, Sirius B has therefore remained anonymous for a relatively long time, its discovery dating only from the 19th century. Let's continue our progress, still within our Milky Way, itself belonging to the local group, which alone includes more than 60 galaxies. During this time, take advantage of it to observe with wonder, between the stars, some molecular clouds or other nebula. Their colors, all more surprising and attractive than the others, can only bewitch you. We cross hotter zones than others, in which hydrogen is ionized. These zones exceed 1 million degrees Celsius. Other zones, colder and denser in dust and molecules, are close to absolute zero, with temperatures lower than -260 degrees Celsius or -436 degrees Fahrenheit. These cold zones, dense in dust grains and gas which gather in interstellar clouds, are, contrary to the hotter zones, immensely large. With a little luck, you'll be able to observe a planetary nebula. But don't be mistaken, it has nothing to do with a planet. It is a shell of expanding gas ejected from its star at the end of its life, a red giant that becomes a white dwarf. This phase, very spectacular, is magical and colorful. The constellations follow each other with incredible quantities of stars. After having crossed some of them, like the constellation of the Unicorn, the Gemini, or the Giraffe, let's go directly to the constellation of Andromeda. Located south of the constellation Cassiopeia and east of the constellation Perseus, Andromeda has 300 billion stars. This constellation in the northern hemisphere, which is A-shaped, is one of the 48 constellations identified by Ptolemy, a Greek astronomer, astrologer, mathematician, and geographer who lived in Alexandria, Egypt during the Roman Empire in the 2nd century. His work is the continuation of a long evolution of ancient science based on the observation of the stars, numbers, calculation, and measurement. He is the author of several scientific treatises, one of which, known as the Almach, means the Great Composition. It is a treatise on astronomy that brings together the most advanced knowledge of antiquity and mathematics and astronomy. Moreover, this treatise has known only a few minor corrections during the following 13 centuries. In Greek mythology, Andromeda is the daughter of Cepheus and Cassiopeia, a royal couple from Ethiopia. The legend tells that the queen Cassiopeia would have provoked the anger of the god Poseidon, god of the sea, by having affirmed that she and/or her daughter was more beautiful than the Nereids, i.e. the marine deities. As a punishment, Poseidon created a sea monster that sacked the country. An oracle revealed that only the sacrifice of Andromeda, daughter of the royal couple, would put an end to this plague. Thus, Andromeda found herself naked and tied to a rock to be devoured by the monster. However, she was saved by Perseus, who, after defeating the sea monster, married her. Moreover, in English, Andromeda is called the Chained Woman. The representations of the constellation of Andromeda in the manuscripts systematically show this young woman, almost undressed and with her hands tied. But let us return to our stars. In the constellation of Andromeda, 3 of them are distinguished by their luminosity. Thus, the main stars of Andromeda that appear at nightfall are Alpheratz for the head, Meroc for the hip, and Almach for the foot, also called Gamma Andromedae. These 3 stars are located on the Great Diagonal of Andromeda, which itself belongs to a huge alignment that goes around the globe. Moreover, this alignment is a major axis for locating the sky. The more the night intensifies, the more other stars appear. Alpheratz is the brightest of all, very hot and shining 110 times brighter than the sun. It is blue-white. Moreover, it has a companion, making it a double star, granting it the title of multiple star. Meroc, for its part, is a red giant, 30 times larger than the sun. Almach, which is also a multiple star, has beautiful contrasting colors, orange and blue. The main star of this duo is an orange giant, 80 times larger than the sun, but especially 2,000 times more luminous than the latter. At least 3 other stars revolve with it. Almach is thus part of a quadruple system. the 3 other stars known to date being blue-white stars of the main sequence. They are consequently hot and very luminous stars. These stars are particularly interesting for the search for extraterrestrial life because their stability time on the main sequence is much longer than that of our Sun. What if a super Earth-like planet orbited one of these stars in the so-called habitable zone? How would you like to meet a life form here, more than 350 light-years away from our beautiful Earth? Still within the constellation of Andromeda, a dark red dwarf holds our gaze. It is Ross 248, the 9th star known to date from our Sun, and distant more than 10 light-years from our planet Earth. The red color of Ross 248 informs us that its temperature is more than 3,226 degrees Celsius, or more than 5,838 degrees Fahrenheit. Our Sun, which is a yellow star, has temperatures of more than 5,726 degrees Celsius, or more than 10,338 degrees Fahrenheit. This difference in temperature explains why the star Ross 248 belongs to the group of dark red dwarfs. This is the main reason why this star is not visible to the naked eye from our Earth. A good telescope and certain conditions are essential. However, today you have the opportunity to observe this main Sirius star very closely. This name specifies that Ross 248 is still in nuclear fusion phase. Hydrogen is transformed into helium. This phase will cover most of the total lifetime of the star before it becomes, as in most cases, a white dwarf. But look carefully, you can see that its intensity fluctuates occasionally. This variability in brightness is explained by the flares that this star undergoes. Unpredictable and of variable duration, these can be spectacular, extraordinary. This fairy tale show makes us forget the environment of Ross 248, and for good reason. It seems that this star exists alone. No planet accompanies it. The nearest star is Gliese 15, still named Groombridge 34. Gliese 15, which is 1.54 light-years away from Ross 248, is a stellar and planetary system comprising at least 2 stars and 2 planets. The main object is the star GJ15AA, or Groombridge 34AA. This variable star is accompanied by a second variable star, much smaller and cooler, GJ15b. These are 2 eruptive red dwarfs that orbit each other in a quasi-circular manner in 2,600 years. 147 astronomical units separate these 2 stars, which represents more than 22 billion kilometers, or almost 14 billion miles. This binary system is accompanied by a super Earth and a super Neptune. Their mass, respectively 3 times and 36 times that of our Earth, gives them the status of multi-planetary system closest to our system. But this multi-planetary system benefits from unusual properties. GJ15AB, the super Earth, makes its complete orbit around its star in only 11 days. This means that 1 year on this planet lasts 11 days. Consequently, this proximity eliminates any hope of life on this super Earth, its surface reaching 276 degrees Celsius, or more than 528 degrees Fahrenheit. These 2 celestial objects then orbit around each other's center of mass, known as the baby center, like 2 children facing each other and swinging by their hands. Similarly, GJ15AC, the super Neptune, cannot harbor any source of life. This gas giant certainly has extremely cold temperatures due to its considerable distance from its star. In fact, it takes about 20 years for this super Neptune to complete its full orbit, which places it very distant from the habitable zone of its star. We will now travel much further, beyond what we can imagine. To do this, our spacecraft must use space-time galleries. Thanks to these, we can move in space-time and reach a galactic country in no time. Hang on, you may be a bit shaken, but it doesn't matter. You'll be captivated, even intoxicated by this fairy-like crossing. We have almost arrived at our long-awaited destination, the Andromeda Galaxy. Look straight ahead. You can contemplate in the distance this luminous object. Contemplate this magnificent spiral in front of you, with its dazzling center and its gigantic periphery glittering with 1,000 bluish lights. Look all around it. 2 other galaxies accompany the Andromeda Galaxy. Admittedly, they are small. However, despite their discrete presence, these 2 satellite galaxies appear in close vicinity of Andromeda, giving it an even more spectacular dimension. Moreover, the limits of the galaxy are not obvious. It seems to be surrounded by a gigantic halo, within which we can see gas particles, as well as a myriad of stars that seem to agitate. The Andromeda Galaxy, like our Milky Way, is an elliptical galaxy with a barred spiral structure. 7 arms are counted, more or less developed. It is approximately 2.5 million light-years away from the Sun. Despite this dizzying distance, the Andromeda Galaxy is one of the most distant objects visible to the naked eye from the northern hemisphere of our planet. Easy to recognize, it is distinguished by its elongated shape and its milky color. The Andromeda Galaxy is also one of the most extensive objects in the sky, with a diameter to the naked eye comparable to that of our Moon when observed from the ground. However, when observed through a telescope, this flattened disk is much larger than it appears. This huge object covers 6 times the apparent size of the full moon. This is why it is easily visible from our northern mid-latitudes. When the night sky is clear enough, it is relatively visible all year round, for at least part of the night. If you need help finding it, look for the constellation Cassiopeia, which is the constellation of 5 stars in the shape of a W or M. The first peak of the M, or the second valley of the W, may represent an arrow pointing directly to the Andromeda Galaxy, which lies between the constellations of Cassiopeia and Andromeda. Despite its distance from our solar system, it's been observed for a long time from our planet Earth. Its first written mention dates back to 964. It appears in the Book of Fixed Stars by Abd al-Rahman al-Sofi, a Persian astronomer and clockmaker. Called the Great Nebula of Andromeda, it was photographed for the first time in 1887 by the English astronomer Isaac Roberts. It was this mistake that led to it being listed as a nebula in Mizer's catalog under the object M31. Then, in the 1920s, giant or supergiant variable stars were identified in astronomical photographs of this nebula. From then on, calculations allowed us to affirm that these stars were indeed extragalactic. This is why Andromeda has only been called a galaxy since 1925. Before this date, it was considered a nebula. For many centuries, it was of little importance to astronomers, except that it was the closest of the big nebulae in the universe. Its appearance as a spiral pocket of gas was all the more attested to, because at that time, for scientists, the universe was limited to our Milky Way. From then on, spiral nebulae, such as the Andromeda Nebulae, were recognized as independent galaxies. In our Milky Way, became one galaxy among others, in a universe without a visible horizon. The immense diameter of approximately 200,000 light-years makes the Andromeda Galaxy the largest galaxy in the local group, with our Milky Way taking second place. The Andromeda Galaxy is the closest spiral galaxy to our own, and contains nearly 1,000 billion stars, about twice as many as the Milky Way. However, its total mass is estimated to be around 1,230 billion solar masses, compared to 1,900 solar masses for our galaxy. If these two galaxies have similar masses, on the other hand, the density of stars in the Andromeda Galaxy is higher. This is why its luminosity is 25% higher than that of the Milky Way. The total luminosity of the Andromeda Galaxy is estimated at 26 billion times the solar luminosity. However, the Milky Way has 3 to 5 times more star formations than the Andromeda Galaxy. The latter seems to have reached a certain state of rest. But if this rest is related to its production of stars, the galaxy is well in motion. Starting from the galactic center, the speed of stars increases to 225 kilometers per second, or 140 miles per second, before decreasing to 50 kilometers per second, or 30 miles per second, at 7,000 light-years, then increases again to 250 kilometers per second, or 155 miles per second, at 33,000 light-years, before decreasing again to 200 kilometers per second, or 125 meters per second, at 80,000 light-years. We can then deduce that the total mass of the Andromeda Galaxy increases linearly up to 45,000 light-years from the center, then more slowly beyond this distance. The mass of the nucleus is then estimated at 6 billion solar masses. Now, let's take a closer look at this huge starry island, drowned in the interstellar cosmos. Let's begin by studying its structure, starting with its center, the brightest part of the galaxy, its bulge. This contains a very compact and active stellar cluster, but for a few decades, thanks to the Hubble Space Telescope, we've known that this bulge is structured in 2 distinct components, distant from each other only by 5 light-years. The first, P1, is the brighter, a very large and dense cluster of old red stars. The second, P2, is much less luminous and hosts a supermassive black hole whose mass is estimated at about 140 solar masses, or 40 times the estimated mass of the Milky Way black hole Sagittarius A. However, this bulge has not said its last word. Indeed, it seems much more complex than it appears. The Hubble telescope has also revealed new images showing a mysterious blue color surrounding this giant supermassive black hole in the heart of Andromeda. In fact, this bluish color revealed a ring of hot, relatively young blue stars 200 million years old, located in the heart of the elliptical ring of old red stars, swirling around the supermassive black hole, thus indicating the exact position of the latter. This newly discovered ring consists of more than 400 stars, tightly packed into a disk measuring only 1 light-year. These stars, under the gravitational grip of the black hole, are traveling very fast, at the speed of 1,000 kilometers per second, 621 miles per second. The Andromeda Galaxy thus has a double core with a gigantic bulge. This double cluster of stars reaches almost 20 light-years in diameter in total. Its box-like appearance seems to confirm that the Andromeda Galaxy, like our Milky Way, is a barred spiral galaxy. Moreover, the bar is visible in the direction of the greatest length of this supposed nebula. As for all galaxy, the bulb remains the most visible part, but the closer we get to this luminous structure, the more easily we distinguish its extent. Indeed, The bulge is surrounded by a thin but gigantic disk whose spiral-like structure reminds us a lot of our Milky Way. Andromeda's spiral arms wrap tightly around each other, but two large arms stand out, separated by a minimum of 13,000 light-years. Although the spiral arms of Andromeda appear to be very close together, they're still farther apart than those of our galaxy. But let's observe this region with infrared. You'll be surprised to discover a multitude of concentric rings, one of which, located 33,000 light-years from the galactic center, contains most of the dust and much of the gas of the entire galaxy. The reason this observation is only visible with infrared light is that the components of this ring are made up of cold dust, with a temperature below -258 degrees Celsius, or below 496 degrees Fahrenheit. You can also see that the disk of Andromeda is not as flat as it seems at first glance. Indeed, it undergoes a torsion, which seems to be related to nearby celestial objects. Beyond the disk of the Andromeda Galaxy, beyond its 220,000 light-years visible diameter, a huge halo of ionized gas encircles the galaxy. This halo is so gigantic that it meets that of our Milky Way. It extends from 1.3 to 2 million light-years in some directions. This is a reservoir of gas that contains enough fuel for future star formation in the galaxy. Moreover, more globular clusters already exist. Thus, this luminous spiral, with its brown and bluish reflections, seems to evolve in the cosmos with an Olympian calm. But this feeling is somewhat challenged when we observe the galaxy for a longer time. If you look closely at this luminous immensity, you can see that a number of stars of a rather rare type are in the process of evolving. About 8,000 stars, old stars that have completed their red giant phase, have expelled their gaseous envelope. In fact, these dim stars are undergoing a phase of instability. They're cooling down before turning into white dwarfs. Thus, despite evolutions over millions of light years, we can affirm that nothing is fixed in time. Not even the stars, nor the galaxies that live in the interstellar medium. This last one is moreover abused by the turbulent, even explosive life of its occupants. But how are stars born? What is certain is that stars are being formed at this very moment in our galaxy, as well as in all other galaxies of the universe. A star is never born alone. During the gravitational collapse of a cloud of gas, dust, and molecules, all these fragments of matter compress, heat up, and shrink, forming a protostellar core within the cloud. This is what astronomers call a star nursery. Then these protostars contract in turn. The temperature climbs exponentially until the inevitable threshold where thermonuclear fusion reactions begin, giving birth to a large number of stars. Each star grows by capturing surrounding matter. They also create each their own accretion disk, in which the aggregates of dust, then the planets, will be formed, each star giving birth to a distinct solar system. The star then shines brightly in the cosmos, thanks to the process of nuclear fusion that takes place in its core. Composed essentially of 70% hydrogen and 28% helium, the star burns hydrogen, its only fuel. When the latter runs out, hydrogen fusion stops, and the star becomes a red giant. Then begins a new fusion, that of helium and carbon and oxygen. This phase, much shorter, makes the star unstable and variable. It then ejects its atmosphere into the interstellar medium. It is at the stage known as the planetary nebula. In its heart remains a glowing part, the white dwarf. similar in size to our Earth, but with a mass identical to that of our Sun. Its density is such that it is of the order of 1 ton per cubic centimeter. Imagine a lump of sugar weighing a ton. Then, depending on its mass, it can continue to shine for billions of years as an iridescent planetary nebula before dying out by becoming a black dwarf. Now, regarding massive stars, with a mass between 8 and 25 solar masses, they follow a longer and more spectacular process. The massive star undergoes a real shockwave when the gravitation can no longer be compensated by its mass. The heart of the star collapses on itself, and a violent explosion occurs. This is the supernova. During the few days following the explosion, the star shines brighter than the galaxy that hosts it. What remains is a neutron star, about 10 kilometers in diameter, spinning rapidly on itself. A pulsar is born, disrupting the surrounding gas of the nebula by its electromagnetic emission jets. Unlikely as it may seem, its density is 1 billion tons per cubic centimeter. Now imagine your sugar cube as heavy as a mountain. As for stars with a mass greater than 25 times that of our Sun, they die by becoming neutron stars as well. However, their mass is such that the pressure of the neutrons cannot counterbalance the spatial gravitation. A new collapse occurs on these neutron stars, leading to a creation of black holes. It is certain that the Andromeda Galaxy contains millions, even billions of planets orbiting its many stars. However, current technology, although already very advanced, does not allow us to observe non-luminous stars distant more than 2.5 million light-years from our solar system. But astronomers are competing with ingenuity and do not cease to observe our galactic neighbor. Moreover, an object seems to have been spotted during a microlensing event in 1999. What if it was indeed a planet? This confirmation would make the headlines in scientific journals worldwide. Indeed, it would be the first hypothetical planet at a distance of 2,185,247 light-years from our galaxy, has been named PA99N2. Its mass is estimated at 6.34 masses of Jupiter, or more than 2,015.5 times the mass of Earth. Imagine that this planet orbits in a habitable zone. Do you think that a life form could be discovered there? This is an essential question that always motivates scientists. We now understand that objects in the Andromeda Galaxy that do not emit light are very difficult to detect. It is even, at present, almost impossible. However, if the planets remain in the shadows for the moment, other celestial objects, each more extraordinary than the last, allow us to admire, with as much wonder, the Andromeda Galaxy. Moreover, a major event was observed in 1885. It is exactly on August 17, 1885, that a supernova was observed for the first time at the observation of Rouen by Ludovic Gully. It was the first supernova observed since the invention of the telescope in 1609. This explosion was of such intensity, exceeding the magnitude of 6, that it was visible to the naked eye between 17 and 20 August 1885. This supernova is all the more historic, as it is still to this day the only one to have been observed in the Andromeda Galaxy. Several other astronomers had the chance to observe this extraordinary phenomenon, but only Ernst Hartwig, from the Dorpat Observatory in Estonia, was aware of its potential importance. Subsequently, in 1989, more than a century after the discovery of this supernova, astronomers from Arizona in the United States described the material that was expelled during the explosion. This is the afterglow, which extends into space, forming a type of nebula called supernova afterglow. The observation of this afterglow, whose matter is ejected at very high speed, several thousand kilometers per second, has led to the conclusion that the supernova observed in 1885 in the Andromeda Galaxy was a type La supernova, not very bright. Thus, a white dwarf from a binary system that could not absorb the gravitational collapse will have caused this thermonuclear supernova. This afterglow will probably be completely dissipated in a few 100,000 years, but for the moment, it still offers us a nebulous spectacle of incredible beauty. Moreover, many other luminous forms should attract your attention, not far from the Andromeda Galaxy. The latter is accompanied by 27 dwarf galaxies, 14 of which orbit around it on the same plane, in a huge disk 1.3 million light-years in diameter and only 42,000 light-years thick. The satellite galaxies of the primary galaxy seem to rotate in the same way inside the disk. Among the stars that make up the metal-rich Andromeda Halo, many are of intermediate age, suggesting that a single dominant merger with a large galaxy has taken place. Moreover, M32, one of the satellites of Andromeda, a small, compact galaxy, also metal-rich, whose red and yellow stars are concentrated around the nucleus, seems to have a direct link with the composition of the Andromeda Halo. The proximity of this small, diffuse ball to the primary galaxy allows comparison of these two very similar formations. Scientists have concluded that about 2 billion years ago, the Andromeda Galaxy engulfed another, much larger galaxy, previously the third or fourth largest galaxy in the local group. The dwarf galaxy, M32, would then be the remaining core of the former galaxy, M32P, formerly much larger. This merger would have created approximately 1/5 of the stars in Andromeda, and would explain the unusual density characteristics of M32 compared to other elliptical galaxies of similar size. Looking at the Andromeda Galaxy, after locating M32 south of the core of the primary galaxy, it's easy to spot another satellite galaxy of Andromeda. Located on the other side of the primary galaxy from M32 to the northwest, you can see M110, next to the massive arms of Andromeda. Here is another elliptical dwarf galaxy, larger than M32, but fainter in luminosity. Unlike M32, M110 does not contain a supermassive black hole. Although it seems very close to the Andromeda Galaxy, it is, however, about 3 million light-years away, the same distance that separates it from our Earth. I'll let you admire this wonderful spectacle that these three neighboring galaxies, and at the same time so distant from each other, offer you. What a magnificent cosmic trio. I now propose that you go and meet a dwarf spheroidal galaxy, Andromeda 1, located 150,000 light-years from the Andromeda Galaxy. This satellite galaxy was discovered in 1972, at the same time as the Andromeda 2, 3, and 4 galaxies. One immediately notices the difference with the previously visualized galaxies. The stars in this galaxy, which are mostly red in color, are distributed spherically around the nucleus. It is a small galaxy with only a few million to a few 100 million stars. Moreover, the vast majority of galaxies belonging to the local group have this same configuration. Its stars, poor in metals, have characteristics similar to those of globular clusters. But these dwarf galaxies, although very luminous, remain difficult to spot in the Andromeda Halo. Another satellite galaxy of the Andromeda Galaxy may also attract your attention. It is the dwarf spheroidal galaxy of Pegasus, also known as Andromeda 6. It is located in the constellation of the Winged Horse. Its distance from our Sun is estimated at 2.7 million light-years. This galaxy should not be confused with one of its companions, DDO 216, which is also a dwarf galaxy in the constellation Pegasus. Indeed, the latter is an irregular dwarf galaxy of Pegasus, and seems to be at a distance of about 3.3 million light-years from our solar system. Unlike the galaxies described so far, this one shows no regular structure, neither sphere nor galactic arm. However, like a nebula, it is rich in gas and interstellar dust, as well as in stars. We will now focus on a duo. Let's move away a little and join Cadwell 18, or NGC 185, and Cadwell 17, or NGC 147, which exist in the southern region of the constellation Cassiopeia. These are two dwarf spheroidal galaxies, gravitationally linked to each other. Thus, you can contemplate this binary system revolving as a couple with an unchanging motion in the halo of the Andromeda Galaxy at a distance of 300,000 light-years from the latter. Cadwell 18 has, on the other hand, a small particularity. It is distinguished from its partner by the intense radiation on a part of the electromagnetic spectrum that it emits in its center, thanks to its very active galactic core. This particularity allows a better observation of its structure. Moreover, its diameter is estimated at 10 million light-years. It is then labeled by some members of the astronomical community as a Seyfert Type II galaxy. These galaxies are characterized by their extremely bright and compact nucleus and their spiral structure. The nucleus of a Seyfert galaxy represents one of the largest known sources of electromagnetic radiation in the universe, probably related to the supermassive black hole at its center. If this hypothesis is confirmed, Cadwell 18 will be the first known Seyfert galaxy in the local group, and the closest to the Earth. The mystery remains for the moment. Moreover, another mystery animates the scientific community about this duo. A third dwarf galaxy discovered recently, Cassiopeia 2, also seems to be part of the binary system Cadwell 18 and Cadwell 17. As such, it may be a gravitationally bound group within the surprising population of small galaxies that orbit Andromeda. But the most massive and easily recognizable is the Triangulum Galaxy, also known as M33. It is also a spiral galaxy from the local group, but not as large. As its name indicates, it is located in the constellation of Triangulum, and its distance is estimated at 2.7 million light-years. Its mass, estimated at 60 billion solar masses, represents only 5% of the mass of the Andromeda Galaxy. A regular spiral galaxy with a disk, its angle of inclination allows us, when the sky is clear, to observe it almost from the front with the naked eye from Earth. The isolated galaxy does not show a galactic bulge around its nucleus, which does not seem to have a supermassive black hole either. On the other hand, the core of the Triangulum Galaxy contains an ultra-bright X-ray source, making it the most powerful X-ray source in the local group. Astronomers are not yet certain that it is a satellite of the Andromeda Galaxy, but the contrary has not been proven either. The Andromeda Galaxy is a real jewel box. Many are the stars that allow it to illuminate this part of the cosmos. If the satellite galaxies that accompany it offer a beautiful ornament, more than 400 globular clusters allow it to sparkle with 1,000 lights. Let yourself be seduced by its stars, more or less tightly packed together. Observe their pulsations, their palpitations. It is a magnificent living spectacle, colorful and luminous, that unfolds before your eyes. Among the star clusters orbiting in Andromeda, Myal 2 is the brightest, not only in the Andromeda Galaxy, but in the entire local group. This globular cluster, also known as NGC 224G1, and located only 130,000 light-years from the galactic nucleus of the Andromeda Galaxy, is immense and very massive. In fact, its size is estimated to be between 2 or 3 times that of Omega Centauri, which is itself the most massive globular cluster in the Milky Way. Myal 2 contains at least 300,000 old stars. The presence of a black hole of intermediate mass in its center is studied, especially since some astronomers suspect that Myal 2 would be the residual core of a dwarf galaxy previously absorbed by the Andromeda Galaxy. This globular cluster seems to have approximately the same age as the oldest clusters in our Milky Way. They probably formed shortly after the beginning of the universe, during the first era of galaxy formation. Among the remarkable objects in the Andromeda Galaxy, an open cluster of young blue giant stars, NGC 206, is visible in the southwestern arm. Stretching over about 400,000 light-years, this bright blue star cloud is one of the largest star-forming regions of the local group. It is also the brightest star cloud in the Andromeda Galaxy visible from Earth. Like most open clusters, it has between 100 and 10,000 stars of the same age, revolving under the same gravitational influence. Another cluster of even more recent discovery is under debate. It is the RBC globular cluster EXT8, one of the brightest and most massive of the Andromeda Galaxy. With 1.14 million solar masses, it orbits 88,000 light-years from the galactic center, and its observation is somewhat disconcerting. The mass of this cluster is not in agreement with the predicted value of its metallicity. Indeed, the measurements of the iron and hydrogen lines, as well as other elements related to iron such as magnesium and sodium, do not agree with the established calculations of astronomers. The more massive a cluster is, the stronger its metallicity should be. However, RBC EXT8 presents a metallicity value well below the expected value. This one turns out to be 800 times lower than the solar value. This difference could be explained by the presence of 2 distinct populations of stars within the same cluster. This observation makes RBC EXT8 a rare and precious globular cluster for astronomers, always eager to understand even more the formation of our universe. Beyond understanding the formation of the universe, researchers are always hoping to find the slightest trace of life, or the possibility of a development of life in any form beyond our planet. Moreover, can the Andromeda Galaxy support life? This is a question that cannot be answered today. The Milky Way in which we live is still a mystery to astronomers. They cannot, at present, affirm whether there are other stars in our galaxy that harbor life, whatever it may be. Imagine then how much more complex it is to answer this question concerning another galaxy, as close as it is to ours. However, the Andromeda Galaxy has very similar characteristics to the Milky Way. Knowing that at least one star, namely our Sun, is capable of offering us life as we know it, why wouldn't there be at least one in the Andromeda Galaxy? By following the ratio of the number of stars present in these 2 neighboring galaxies, and knowing that Andromeda probably has at least 10 to 12 times more than the Milky Way, we can allow ourselves, hypothetically, to evaluate a dozen stars that would be likely to host a form of life within the Andromeda Galaxy. Finally, a big surprise awaits you. As you have seen during this intergalactic journey, although the stars seem to be frozen in the cosmos, this is not the case. Everything is in movement, rotation, fusion, attraction, expulsion, explosion, collapse, birth, death, collision. Celestial objects cross each other, brush against each other, orbit with others, leading a celestial choreography with a serene appearance. Nevertheless, it happens sometimes that they meet with an unheard level of violence. Although these collisions are not so frequent considering the number of these objects scattered in the cosmic immensity, they can have heavy consequences and impact considerably their environment. You were able to observe the movement of planets alongside their respective stars. You've also admired the birth of new stars in the heart of the marvelous and very active nebulae. But do you know that each galaxy also follows its own trajectory? You certainly understood this when the Andromeda Galaxy was mentioned, which probably digested a large part of an old neighboring galaxy, M32P. Nevertheless, did you realize that if two major galaxies could merge, it could affect our part of the universe? In fact, this is inevitably what is going to happen. The Andromeda Galaxy and the Milky Way are about 2.5 million light-years apart, for now. The gravity of these two largest galaxies in the local group causes such a powerful pull that they're hurling towards each other at 402,000 kilometers per hour, or 250,000 miles per hour, or 9.6 kilometers per day, almost 6 million miles per day. But how can scientists confidently predict this future collision? It is, in fact, thanks to their mathematical understanding of the physical laws that govern the movements of celestial bodies. Newton's law of gravitation allows astronomers to analyze and therefore anticipate the trajectories of the various objects observed. In addition, the European Space Agency's Gaia mission, which was launched in 2013, has collected a considerable amount of usable data. These synthesized data have made it possible to create an extraordinarily accurate three-dimensional map of more than 1 billion stars belonging to our Milky Way, but also well beyond. Thus, this vast census has made it possible to map their motions, luminosity, temperature, and composition, making it possible to push forward studies that will allow, in the more or less near future, to answer major questions related to the origin, structure, and even future evolution of our galaxy. In addition, the Hubble Space Telescope, thanks to a multitude of photos taken at different times, has allowed NASA scientists to measure the speed of movement of stars in the Andromeda Galaxy. The highlighting of their displacement was possible thanks to their superposition on blurred galaxies located in the distant background. Moreover, the huge gas halo surrounding Andromeda, also photographed, seems to come into contact with the Milky Way halo. If the hypothesis that the distance between the two galaxies is getting smaller has been affirmed for some time, on the other hand, the collision between them has not been so obvious to confirm. After all, they could simply be brushing against each other, allowing their star streams to become somewhat entangled, forming filaments. But the scientific community has concluded that the Andromeda Galaxy's own motion is tiny, which means that its future trajectory is relatively easy to anticipate. As a result, astronomers are able to predict that the Andromeda Galaxy will collide head-on with our Milky Way, creating a single, huge galaxy. Moreover, they've already named this future and gigantic galaxy. It will be called Milkomeda. This name results from the contraction of Milky Way for the Milky Way and Andromeda for Andromeda. Fortunately for us, the considerable distance between these two galaxies leaves us about 4.5 billion years before this process of galactic fusion, or coalescence, begins. Here, you're in front of two monsters of the cosmos, facing each other and getting ready for a future confrontation. But will it be a fairy dance of the stars, or an explosive confrontation? To be honest, when the collision occurs, it is unlikely that celestial objects will actually collide. Indeed, galaxies are so diffuse that the stars within each of them are prodigiously distant from each other. These considerable distances between stars give them little chance to collide. When the time comes, the Andromeda Galaxy and the Milky Way will make their first close passage at more or less 400,000 light-years from each other. Then, it will take another 2 billion years for this process to give birth to a new supergalaxy. In the meantime, this duo will start a cosmic dance, with periods of approach and periods of distance, sowing gaseous and starry tendrils in its path. This stellar choreography will upset the constellations, thus offering, over time, a new pattern to our starry sky. Our Milky Way will undergo a global reorganization, just like the Andromeda Galaxy. Their spiral arms will be dislocated into a myriad of chaotic stars. According to NASA experts, these two spiral galaxies during this very long process of fusion will give birth to a giant elliptical galaxy, probably quite red. What will happen to our Sun, our planet Earth? Their respective places will of course not be preserved. Two fates seem to be taking shape. One would dictate that the solar system would be ejected at some point from the supergalaxy, at the same time or after the collision, causing little disturbance to the Sun and the surrounding planets. The other fate, more uncertain, would cause a displacement of the solar system towards the center of the collision. The latter would then be at the mercy of supernovas in the heart of the galaxy in fusion. In any case, the Earth as we know it today will already be gone. All terrestrial life will have already disappeared a long time ago. Why? Because our Sun itself, in this same period of time, risks undergoing deep transformations, apart from the collision in question. Indeed, the star to which we owe life on Earth also has a limited lifespan. It could even be that our solar system will no longer be the same at the time of the collision between the two galaxies, thus depriving the Earth of this celestial spectacle. The reason? The death of our Sun, which is expected to be in about 5 to 7 billion years. But by then, our Sun, currently considered as a yellow dwarf, will have become a red giant, heating more and more its closest neighbors, because of the exponential increase of its power. Mercury and Venus will be disintegrated. Our planet Earth, as well as Mars, will be fatally burned. However, this is only one scenario. Some scientists speculate that the Earth's orbit could spiral outward, taking the Earth away from this fiery inferno. Dear space traveler, our tour is coming to an end. We hope that this intergalactic exploration with your head in the stars will have dazzled you, and that its dimension, as spectacular as intriguing, will not have left you unmoved. Without a doubt, this excursion, although full of teachings, is still far from giving you all the secrets of the Andromeda Galaxy, and even more of the universe. In fact, will all these secrets be revealed one day? Haven't you noticed? If with each technical advance, discoveries, each more extraordinary than the other, are made, new mysteries appear, offering scientists new paths to follow, to infinity and beyond.